Car travels along a straight highway. During the first half of its journey, it maintains a constant speed of 80 km per hour. For the remaining half of the journey, the car encounters traffic and its speed varies. The car travels for the first half of the remaining distance at a slow speed of, I forgot to mark first half. Then the car travels for the first half of the remaining distance, guys. With this and the second half of the remaining distance with this speed. Oh, that's pretty fast. What is the car's average speed for the entire trip? So we have again a case of analysis. So we have this diagram. So first half and then half and half again. First of the journey is 80 kilometer per hour, and the car travels for the first half of the remaining distance at 50 kilometer per hour, and then 110 kilometer per hour. So we'll call the distance as x or 2x. So this will become x and this will become x. What's the car's average speed? So we have the working. So we have the average speed is equal to, it's defined as total distance, entire thing divided by total time. So total distance is 2x plus x divided by total time. Time would be distance by speed and distance by speed. So we have x that we can cancel, and this is 4. Remember, this is 1 1 1 and 1. Yeah, 4 getting divided with 2 1s are 2 40s are. Okay, so I'll use calculator that you guys can do it on your own. 40 plus 1 by 50 plus 1 by 110. That's a weird number. So 119 divided by, yeah, I got it right. 2200. So this is a weird number. So this is 8800 by 119 kilometer per hour. The displacement of an object is given by the following equation. Hint, the object will change direction when there is a sign change. Okay. Determine the moment in which determine the moment in which when the object will come to a stop. Determine the direction of the velocity before and after the object stops. Illustrate the trajectory of the object as it moves along a straight line from time t is equal to 0 seconds to t is equal to 3 seconds. This is a good question. Tougher one. So we have an object that is clearly moving along a straight line. That they made it very clear. We have point A. That's where it's starting off with. At time t is equal to 0 seconds. Now, to understand anything of this, what should I do? I should substitute, as simple as that. So for x or t is equal to 0 seconds, x is clearly 0. T is equal to 1. X is equal to 2. Again 0. No, wait. 2 minus half, 1.5. So many unit. And t is equal to 2. x will be equal to 2 times of 2 is 4 minus 4 by 2, that is 2 unit. This is displacement, right? T is equal to 3, x is equal to 6, 9 by 2. So 6 minus 9 by 2, 1.5. Wait, how is that possible? 6 minus 9 by 2, 4.5. Yeah, it is. By now, we should have got a negative number. What did I do wrong? T is equal to 0. This is right. T is equal to 1, 2 minus half, 1.5, right? T is equal to 2, 4 minus 2, 2. That's correct. Oh yeah, it's going back now. Okay, it is reduced. Correct. Perfect. So I can see a change in direction. So how can I tell that? See, at t is equal to 0, it's at the starting point, x is equal to 0. And it moves 1.5 unit forward. So let me indicate 1.5 with something like this. Say this is 1 unit. I'm making up a scale now for better understanding. You don't have to do it in your exam. Oh yeah, I keep forgetting that you guys are in 11th grade. So all that maturity you guys have to have now. You can't unnecessarily write things which are not needed for your exams. So we have 3 units of distance, right? So first thing is the object at t is equal to 0. It's over here. I need not write this. I think I'll just go with 0 sec. Then 1 second, it's at 1.5. So this is 1 and this is 1.5. So this is 1 second. And at 2 second, it is at 2. So this is at 2 second. And at 3 second, it's back. So what's happening? So obviously the vehicle had to go forward and slow down somewhere and come back. Only then this is possible. Agree? Now the question is determine the moment in time when the object will come to a stop. That's the question. So when it's starting, it is with certain velocity that it started with, and it goes forward, and it has to stop before it can turn back. Since it's a movement along a straight line, it cannot take a U-turn per se. It has to stop because it's along a straight line. So that being the case, somewhere along this time frame between 2 and 3, the object stops. How do you figure it out? That's the question. How do you figure the answer out? The moment the object turns, that's where the velocity is 0. Okay. The moment the object turns, the velocity is 0. Now, how do you find the velocity? Differentiating x with respect to time. So we have dx by dt, which is equal to 2 minus 2t by 2. Again, I'm not going to detail how I got this answer. So that's R. Now, the time when velocity is 0. How do you figure it out? Make dx by dt. Dx by dt will be equal to 0. And now we are substituting 2 minus t is equal to 0. So t is equal to 2 seconds. As simple as that. So that is our A. Then B, determine the direction of velocity before and after the object stops. Before it was, say, moving to the right. So I don't have space over here. So I'll just mention it over there. Before it was right. And now it is, after that it is left. illustrate a trajectory of the object as it moves along a straight line from, okay, that we have done already. Yeah, actually we have done. So if you guys want to, we can just do this, and point of time where it turns is at 2 seconds itself. Wait, what? At 2 we got, okay, this is not nothing. Perfect. So this is how it would be. Actually, we have drawn that also. Okay. So we have drawn that as well. So it's over here, 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 and here. Do that. Okay, yes. So that's that. So this is related to scale. So I can erase this. You guys can actually use a scale and do that. So this is your answer. So it's spread across. So but if not, this is C. This is A, and B, I have written it here itself.